Hello and welcome to this first chapter in Business Data Analytics 330, Structured Data Analysis. And so what I hope to do is have a video, audio file for you for each of the chapters that we'll be covering in this course. And so we'll start with chapter 1. And after we finish each chapter, I believe you're going to have some kind of concepts quiz. And so all that's explained in the syllabus, and the exams will be underneath the exam link on the course website. So for chapter 1, we'll be looking at the relational database. So this is kind of like a high overview of what relational databases are. So we'll define that. We'll look at how they originated, how we got to the relational database, look at the relational database model, then look at how it's used in different types of systems, and that is the relational database management system, and then what's beyond the relational model. So one of the first questions that you might ask would be, why do we want to teach a database class in a business data analytics course? So one of the first things you need to understand is that in the 60s, 1960s that is, when we had computers being used in businesses, that the information that the businesses used were stored in the databases. And those computers were centralized. Not everybody had a computer. In fact, they were probably mainframes or mini computers, and you had to request everything that you wanted from the data so they could be generated into reports. Now, with those requests went to a person in IT who had specific knowledge of where the data was and how to access it. And so if it was in a database, then they needed to learn SQL or SQL in order to access that data. Once relational databases were developed, they became a little bit more user-friendly, and then users could use their own skills in order to access that data and build their own reports. Sometimes they wanted to find out certain pieces of information that maybe that if they had to file a request to get the report, it wasn't high on their list of things to do, and it may take months before they could get that report. So with relational databases, it was easier for the actual end user to just go out and query that information and build their own report, or just see what the results of whatever they were looking for. Now, moving forward, as an analyst, you may be asked to help build or define what fields would go into the database. If you're looking for data that's spread across multiple tables, you need to have some idea of what data would be linked to other types of data. And so that's one of the reasons why we're teaching about databases in this class. And so if you become a data analyst, I would hope that you'd learn more about databases and the different types that are currently being out there. Now, for this semester, we're going to predominantly talk about a relational database. But if you move on out of here, the new types of databases are called NoSQL or NoSQL. And they organize data a little bit differently, but you still need to have to understand, how am I going to be able to retrieve that data, and which database model is the best one for my business. So the next thing I want to answer is, why do databases exist? So as I mentioned earlier, they've always existed. They've been around since the 1960s, and it's a way that organizations can organize that data and get access to it fairly quickly. So in today's world, though, a database provides you with a good starting point for all your data analysis. And so you need to understand that data When you collect it, it's just raw information. I shouldn't say raw information, it's raw facts. When you organize those facts, they become meaningful. That meaningfulness then becomes information. And when we can make a decision with that, that becomes knowledge for us. You can also think of this information as data being put into context. And then that becomes information. The next question is what is a database? And you can think of it as usually a large collection of data that's organized especially for rapid search and retrieval. And that's a definition that you would find in the dictionary. Our textbook gives it a definition as an organized collection of data used for the purpose of modeling some type of organization or organizational process. Some examples that you've used are TopNet, maybe the WKU store site, the WKU library site, Amazon, Google Maps, Indeed, LinkedIn, so on. And if you think about it, every app that you have on your phone is an application, and has a database on the back end. I shouldn't say every, but a lot of them have a database on the back end where it's storing information, and then you retrieve it and that gets displayed to you. Now, another way to think of a database is when you look at the hierarchy of data. I'll go ahead and type that out here for you. So here's what I mean by hierarchy of data. Probably in 141, your beginning computer class, you learn that everything in a computer is represented by bits, which are zeros and ones. A collection of bits leads to a byte, and a byte represents a character. So I guess we could put character out to the side here. And so I would say from here on, I always just go, a group of related characters forms a field. A group of fields, that is the data that's underneath each field, forms a record. And a group of related records forms a table. We could actually save this table as a file at this point. A group of related tables becomes a database, especially in a relational database. And then beyond that, a group of related databases becomes a data warehouse. Now, that's not to say that any one of these, starting with the table on up, couldn't be its own file, or it is a file. But I think if you think of this, that if I have a bunch of records and I put them all together, then that forms a table. If I have a bunch of tables and I link them together, that becomes a database, and so on. And so if I'm looking at Excel, and I've got one pulled up here, I'll try and make it small enough to fit on our screen. And I just pulled a random file that I had used in another class. But here we have Excel, and we might not see all of the fields. But this is what we mean by a field. These are column labels at the top, so they're sometimes called field names. So the field names are listed at the top of your table typically, and then underneath that I have different pieces of information that correspond to these field names. These field names can also be called attributes. But if I have a group of related field names, all of this right here, a group of related field names becomes a record. So that's a record. This is a record. That's a record. All of these records together forms a table. And that's what we've got here, is a table inside of this spreadsheet. Now, if I wanted to relate these tables to other tables, that's where it becomes a database. Now, on its own, this could be a database. If I don't have just one table in my database, then that's the database. But what I mean by related here is, okay, I have somebody that has a customer ID 1. Well, that's a number. How do I know where customer ID lives and what their first name is, their last name? All of that information would be kept in another table. And I could relate the two tables based on this field name. And we'll get more into this later on. So don't get overly concerned with this now. You'll see how this works later. But that's what we mean by a database. And so when I want to retrieve any information, I have to know which tables need to be linked up to get all of the information out of both of them that I want. If all the information I want from my report or what I'm wanting to know is in this one table, then that's all I've got to use is this. All right, so that's what a database is. Now, your book talks about different types of databases, and they can be broken down into two different broad categories. One is operational, the other is analytic. When we talk about operational, we can talk about transactions. So these are the type of databases that businesses would be using in real time. So as something changes, it actually grabs the information and it writes it to the database or updates the database. So this is data that's gathered, on an hourly basis, a daily basis, whenever there is a transaction. So it's up to date in real time. So examples might be retailers, manufacturers, hospitals, shipping, so on. Then there are analytical databases. These are the databases that your book doesn't mention it, but they're the ones that are like a snapshot of the operational database. And what I mean by snapshot is we say it's at noon today, we go in and we collect all of the data that's in the operational database and we make a copy of it. There are no more changes being made. So in our copy, then we put it into this analytical type database. And now we can analyze that without having to worry about our numbers changing or anything. So this is typically going to be called your online analytical processing, or OLAP type of databases, or have that ability. So they're historic and time dependent. And so things that you can look for there are looking for trends or something that's happened over time, some kind of statistical analysis that'll show you that this is happening over time. Maybe when you're doing graphics, you would see that. You would also use this data to make strategic decisions with. Like I said earlier, the data is very static. It probably wouldn't change much over time. It rarely is changed unless there's some major thing that goes through with that. Some examples would be chemical labs, geological companies, marketing analysis firms, and so on. When we come back, we will start with this question here in the chapter, and we'll have a second part, and I'll see you shortly.